With cloud solutions being a common infrastructure strategy across tech space, the need for ensuring secure network connections and data encryption in the internet become really big requirements. One of many solutions available in the market that's deemed reliable in satisfying these requirements is OpenVPN. However, oftentimes with OpenVPN, we get constrained by the difficulties in setup, the need for low-level knowledge, and maintainability of the solution. What if I tell you that there is an easy and automated way of setting up OpenVPN using Docker containers? Hello, you're in Pablo Spot. I'm George. Today, I'm going to show you how I automate the process of setting up OpenVPN as a virtual private network solution. I'm going to talk a lot about Dockerization, so this video assumes that you have at least some basic working knowledge of Docker. There are a lot of things to unpack and talk about on this video, so I hope I could keep you all the way to the end so you get to see not just my thought process, but also how my whole setup is done. So, let's start coding. But before we do that, thanks to the amazing sponsor of this video, AppCloud. If you're in the lookout for a high-performance cloud solution, AppCloud can get you sorted. With a user-friendly, easy-to-navigate platform, transparent pricing, and responsive customer support to pride for, AppCloud can bring ease and reliability in your cloud journey. AppCloud has various data center locations that get your geo-presence covered and helps with the compliance requirements and data sovereignty that is mandated by GDPR. If you need database servers, infrastructure for your Kubernetes clusters, private network solutions, or cost-effective and developer-friendly server instances, check out AppCloud. With my promo code, you can get an extended 30-day trial and $50 credit when you sign up. The link is available at the top of the description below. I will leverage on an existing OpenVPN Docker image for my setup, and I also want to have everything run via an automated script. So the first thing that I need to do is write up a bash script that I just run and take care of putting everything together. So let's create that bash script. I will define some variables that I need to refer to later on, starting with the image name. I need to be able to use this Docker image into my session, so I'm going to run docker pull. Now, let's generate the OpenVPN server configuration. So what I need to do is to run a command inside a ephemeral container of the OpenVPN image. The first part of this command that we need to understand is the volume mounting, which is right here. We want to mount a host directory into the Docker container to be able to extract the generated OpenVPN configuration file. So what I'm going to do is head to the top of this script and define a new variable called VPNdir. And then I want to make sure that everything is cleaned up and the directory is recreated at the start of this script. The reason I'm doing this is so I can rerun the script as much as I wish, and it will always give me a new set of files to work with. And so now that I've got a OpenVPN directory, I can go back to my Docker run script and update the local directory that I will mount. The mounted path in the container, which points to /etc/OpenVPN, is just a standard path that OpenVPN will use to store its generated files inside the Docker container. I am generating my OpenVPN configuration file, and this mount will allow me to get access to it. This is just making it easier for me to be able to add or enrich or add more settings in the configuration file that I need specifically for my setup. The last component on this command involves running a library inside the container called ovpn genconfig. This is the main command that will generate the OpenVPN configuration file, as the name suggests. And when running this command, I need to pass a parameter that points to a UDP endpoint. I need my VPN server to be accessible from the internet, so I need to ensure that this UDP endpoint is set to use the public IP of the host where it will run. So I will define a new variable called public IP. And to fetch the public IP of the box that I will run this script on, I will run a specific curl command like so. The next variable that I need to define is the VPN port. The port that I use here is arbitrary, so you can use any valid non-conflicting port for your setup. So now that I have my public IP and my VPN port, I can then go back to my docker run command and update the UDP endpoint. This would be a good time to test the script with what I have written so far. And I need to be able to execute the script, so I am going to change the permission to executable. And now I am going to try to execute the script. So that completed successfully. And as you will notice here, there is a new directory called vpndir that is created after I ran the script. And if I expand the contents of this directory, my openvpn configuration file is there. So let's open that file. And then from here, I can then start enriching the entries of my configuration file. So if I head all the way to the end of the file, for example, if I want to set inactivity timeout of 10 minutes, which is also 600 seconds, I can add this entry in the configuration file. This particular configuration entry will enforce my OpenVPN server to terminate client connections that is inactive within 10 minutes. This would help manage the load on the server from any inbound connections. But because I'm trying to set up a script to take care of all the necessary initialization on my setup, I need to be able to incorporate this change to the configuration file. The first thing that I will do is define a new variable on top of my script called inactive timeout and set the value to 600. And then I will append the configuration entry that I need into the OpenVPN configuration file like this. So now I'm going to try to rerun the script. And the expectation is that the inactive configuration entry should be added automatically into the VPN configuration file. So the script has completed successfully. Now let's have a look at the OpenVPN configuration file and then check all the way to the end of the file. And my inactive configuration entry is added automatically, which is good. So far, everything looks good. So let's close this configuration file. The next step that I need to do is to initialize the public key infrastructure, or PKI, for my OpenVPN setup. I am not going to attempt to explain in depth what PKI is. However, think of this as the underlying setup and files that are generated to ensure some basic security when connecting to my OpenVPN server. After all, I am setting up a virtual private network, so some level of network security needs to be put in place to make it a reliable solution. OpenVPN is bundled with easy RSA tools, which I will use to initialize the PKI. The ovpn init PKI is the command that will initialize the private key infrastructure. Notice that I pass no pass argument on the command, and this is an indication that the private keys that are generated will not require password. This is a security flaw on the setup that you need to be mindful of. Because I'm doing an automated and non-interactive setup, I need to do it this way. But this should not stop you from exploring a more secure setup where you provide passkey and manage the generated keys in a more secure fashion. Because I am aware of this security flaw in my setup, I will then need to make sure that I set up safety traps outside of my OpenVPN configuration to ensure that this vulnerability is not going to be exploited. So more on this later. Now back to this command. As part of my automation of initializing PKI, I also need to make sure that this command is run with non-interactive fashion. This means I need to inject environment variables into the command that will allow me to achieve this. The first environment variable that I need to add is the easy RSA rec_cn. So this environment variable holds the canonical name when setting up all the necessary certificates for my private key infrastructure. And then lastly, to make sure that the setup does not require prompts and expect some kind of interaction in the process, I also need to inject another environment variable called easyrsa batch and set this to yes. By now, I have all my PKI files as well as my VPN configuration files ready to be consumed by my OpenVPN server. So at this point, I am going to run a command that will start my OpenVPN server. There's a number of components on this command that we need to dissect and understand. I have here my usual volume mounting so that the VPN server will consume the files that I have generated from the previous commands. I am running the container in detached mode, which means I'm pushing the process of container startup in the background. For port mapping, which is right here, I am exposing the standard UDP port that my OpenVPN server listens to for requests. So when I generated my OpenVPN server configuration, I passed a UDP endpoint that contains the host public IP address and the custom port. The custom port is what I'm going to set as the host port. When the container runs, the OpenVPN server inside the container will be listening from UDP port 1194. The name parameter right here is just a convenient way for me to identify the OpenVPN container in case I end up running several containers on the host. The last set of parameters involve setting up capability additions inside my container. I am setting up a VPN server, so I need to ensure that my container is capable of running network-related activities. But I would like to point out that this is another security flaw that I need to be aware of. So now that I have a command to start the OpenVPN server, I then need to generate client credentials that my OpenVPN server will recognize. When running this command, I want to ensure that the client certificate associated to the client build is only valid for 1 day. And to achieve this, I need to inject an environment variable called easyrsa cert expire and set the value to 1. This is one of many safety nets that I'm putting in place to manage the security flaws that I have pointed out earlier. This particular command runs the easyrsa binary with the argument build client full to indicate that we are generating a client profile. Some user value here is arbitrary, and I'm passing a no pass value to indicate no password for the client profile. To set my OpenVPN user, I am going to define a new variable. The value for this variable is arbitrary. So I'm going to go back to my docker run command and change the reference to some user to my OpenVPN user. So now that I have a command that will generate the client profile, I need to add the final command that will generate the OpenVPN client file that will end up being distributed to users. In this command, I'm running the ovpn get client command, passing the OpenVPN client username that I want the file generated for, and then I redirect the output to a file. So that is all the command that I need to automate everything. So now let me try to rerun this script on its entirety. So that script completed successfully, which means the script works on my machine. What this also means is that I've just made my local machine an OpenVPN server. And to verify this, let me check if there's a container called OpenVPN server running on my machine. And there it is. And also notice the OpenVPN client that has been generated right here. So this is the file that will be provided to the users who would like to connect to the OpenVPN server. But I'm not going to have my machine set up as OpenVPN server, as that will not be an effective way to show you how this works. Instead, let's go ahead and set up an OpenVPN server using an app cloud instance. So let me switch to my browser and log into my AppCloud web console. So what we need to do is click on servers. So for location, I am going to choose one of the US regions. I'm going to use the bare minimum capacity for this setup. So I'm going to use this and then leave everything else the same except for operating system, where I'm going to use Ubuntu server and then change the version to the Jammy Jellyfish or 22.04. Everything else can stay the same. And then on the login method, I have already associated my SSH keys into my UpCloud account. All I have to do is make sure that this is ticked, and then all the way to the end, click deploy. So now that the server is running, let's go ahead and connect to it. So let's take note of the public IP of the instance, and then switch back to my VS Code session. And then on the terminal, I am going to SSH to the box using my SSH private key and the root account. So I have successfully established connection to the box. I should refrain from doing anything on the box unless I'm using something that is not root. So I will create a non-root user on this box. And then I am going to grant sudo access to this non-root account. I also need to make some changes to make sure that I don't get prompted every time I run a command using the non-root account. What I need to do next is to copy the same set of authorized keys that have been set up on the root account into the non-root authorized keys. The first step for this is to temporarily copy the authorized keys files in the temp directory. And now I'm going to sudo into the non-root account and then generate SSH keys, and then move my temporary authorized keys into the authorized keys of the non-root account. So let's quickly verify the permission on the authorized keys. So we want to change the ownership of this file to non-root. Perfect. So that's now all done. Let me exit this session. And now I can set aside accessing the box using the root account and instead connect to the box using non-root. So now I'm ready to go away and configure Docker in this UpCloud instance. And once it's ready, we can resume the rest of the steps for this setup. So I have completed the installation of Docker on my UpCloud server instance. So if I run Docker version here, that returns the output with all Docker details in it. Now what I need to do is to transfer my init OVPN script into the box. So let me quit my current server session. I'm now back to my local machine. So what I will do is transfer my script into my UpCloud instance using SCP. Now let me log in back into the server and then list the files on this directory. And there is my script, init ovpn.sh. So does it have an executable permission? Yes, it does. So what I need to do now is run that script. The script completed successfully, so let's verify that the OpenVPN server container is running on the box. It does, and let's also check if an OpenVPN client file is generated in this directory. So there's my OpenVPN client file. What I need to do next is extract this client file into my local machine. So let me exit my current UpCloud instance session. And then on my local session, I will create a new directory here called from instance. This is just so I can differentiate the client file that I generated earlier from the file that is generated from the UpCloud instance. Now I'm going to run the scp command to extract the file from the UpCloud instance into my local machine. Now if I list the contents of this directory, and there's my OpenVPN client file. Now let's check if this works. So let me open my OpenVPN client. And then I am going to drop the client file under the file section of the app. Before I start the connection, let me first pull out the current public IP of my machine. The reason I'm doing this is because when I establish connection to the OpenVPN server, my box will assume the public IP of the OpenVPN server, which will then allow me to leverage on the instance and become part of the network that is created by the OpenVPN server. So I've got that current public IP address on my machine. Now let me go back to my OpenVPN client and start connecting to my OpenVPN server. So my connection has been established. Now if I go back to my terminal session and run the same command to pull out the public IP address, the output shows that the public IP address on my machine is the same public IP address of the OpenVPN server instance. And this is an indication that so far everything works fine. Now let me close my VPN connection temporarily and then go back to my VS Code session. Remember that we have a number of security flaws that we need to address. And one of the measures that I'm going to put in place to manage these flaws is to configure a firewall on my VPN server. So let's go back to my AppCloud web console. Click my AppCloud server instance and head to the firewall section of the instance. As you can see, the firewall settings is currently disabled. So what I will do is update this and filter out access to my VPN server and at the same time enable my firewall settings. So let's have a look at the rules that are currently set on this by default. So currently inbound traffic is empty. So I am going to add a rule. Change the protocol to UDP. Source IP, I'm going to set this to a single IP address and add my original host public IP address. And then I will update the target port. Remember earlier when I set up the server configuration, I used port 3000 as the custom VPN server port. This is the same port that I will allow on this rule. Now I'm gonna go ahead and save this, click OK. And then make sure to click the Save Changes button right here. And then enable firewall right here. In fact, to test these firewall settings, what I will do is edit my current rule and deny all incoming traffic to the server. I also need to make sure that the default rule right here is set to drop to deny all traffic by default. So now let me go back and open my OpenVPN client and try to establish connection to the server. Notice here that I'm not able to establish connection to the server at all. So let me stop that attempt to connect to the box and then go back to my firewall rules and then reinstate the rule to allow traffic from my machine. So what this rule tells us is that any connection to UDP port 3000 coming from my host public IP address to the VPN server will be allowed. So let's make sure that the Save Changes button is clicked and then wait for a few minutes before we attempt connection once again. Now let me head back to my VPN client and then try to establish connection to the box. And now I am connected to my VPN server. What this means is that I can manage who can have access to this box via the network firewall rules and allow only those that I know of and legitimately require access to the server. So let me go ahead and stop my VPN connection and then go back to my browser. In tech, we normally have several servers that are running in a private network that we control access to, like, say, database servers, internal application servers that are running processes that do not need to be exposed to the internet, or some other infrastructure servers like your in-memory server. In some occasions, you will require someone, especially say a developer, who is trying to troubleshoot a production issue to gain access to these servers. And without having to relax some existing restrictions and firewall rules to the private servers and services, this OpenVPN solution is one option you can explore. Having this set up as a Docker container makes it even easier to create and throw away. So somehow, this is sort of a quick and easy solution. That is all I have for today. If you stayed with me up to this point, I hope you've picked up something from what I've covered. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya!